We can start number 19 by at least summarizing what we've got. We've got a box with 20 transistors, so N is equal to 20, and 6 are defective. So we've got 6D and 14, say, D primes, right, non-defectives. And we're going to draw a sample of 5. So we've got 20 altogether, and we're going to choose R equals 5. And what we want to know is, what is the probability that at least 4 are defective? So we're looking here for the probability of getting at least 4 defectives. So we want to find the probability of getting at least 4 defectives. So how do we get at least 4? I think that's going to be this. At least 4 means we could get 4 defectives or 5 defectives, right? What we're doing here, remember, is we're choosing 5, and we want at least 4 defectives. So how do you get at least 4 defectives? You could get 4 defectives or 5 defectives. So I think we can write this like this. This is what we're looking for is this. The probability, I'm going to write a square bracket here, of, now, to get 4 defectives out of, and we want 5 things all together, and I want 4 of them to be defective. So what we have to have are 4 defectives and 1 non-defective, or, now over here we want 5 defectives out of 5 objects. So we want 5 defectives and 0 non-defectives, right? That gives us 5 altogether. Now, this is a probability problem, and what we're doing is in this box of 20, we're reaching in and getting 5. Now, any group of 5 is just as likely as any other group of 5, so the sample space is equally likely. And so what we're going to do here is we're going to use this idea right here that the probability of some event is equal to the number of elements in that event divided by the number of elements in the sample space. That's what we're going to use. So let's get the number of elements in this event. We're going to do that by, now this is our Chapter 5, counting techniques. What we're going to have here is we're going to use, all right, so we're looking for this one right here. Out of 6 defectives, we want 4. It's a combination, any 4, no order implied here. So we want out of 6, choose 4. And then out of the 14 non-defectives, choose 1. Does that make sense? Out of the 6 defectives, right, 6 defectives, choose 4. And out of the 14 non-defectives, choose 1. Or, now that's a plus. Now out of the 6 defectives, we want 5 of them. So out of 6 defectives, we want any 5. And then out of the 14 non-defectives, we don't want any because we want all 5 to be defectives. Now, that is the numerator. That's the number of elements in the event. We need to get the denominator here, the number of elements in the sample space. So let's draw our fraction bar. Now the sample space is this. How many elements in the sample space? Well, what are we doing? Out of 20 objects, we're drawing 5. So our samples, number of elements in the sample space is this. Out of 20 items, choose any 5. Okay, there we have it. We've done the actual mathematics. Now it's just some computation. And on my calculator, when I did this, I got 0 point, rounding off to 4 places, I got 0139. 0139. Now over here in number 20, we've got 4 cards that we're going to draw from a standard deck of 52. Now, in a standard deck of, what we want to know is, what's the probability that they're all clubs? So we need to know something about decks of cards. And in a deck of cards, let's draw it here. Here's our box. And what we have are 52 cards, and from these, we're going to draw 4. And the way this works is this. Yep, that was a telephone. I had to answer that, or it would have kept ringing. It was my mother. She wanted to know if I had a real job yet. So anyway, let's go on. So what we're going to do is, out of these 52 cards, we're going to draw 4. And the way this works in a deck of cards is like this. We're going to have 13 of each of 4 suits. So we're going to have 13 clubs, 13 spades, 13 diamonds, and 13 hearts. So what we want to know in this problem is, what's the probability of getting not 13, probability of getting, what, 4 clubs. So what we're doing here is we're drawing 4 cards out of these 52, and we want 4 clubs, so how about if we write it like this? This is going to be the number of elements in the event, that's getting 4 clubs. There's 13 clubs from which to choose. We want any 4 of them. Then 52 minus 13 is 39. There's 39 other cards, and we don't want any of those. And then, so this is the event, right? 4 clubs out of 13, and none of the others. We don't want any spades, diamonds, or hearts out of the other 39 cards. And the number of elements in the sample space is just this. There's 52 cards altogether, and we're drawing 4 of them. And my calculator shows, all right, so here's the actual mathematics. We've got it. Now the rest is just pushing buttons on the calculator, and I got 0.0026. So if we round it off to like 3 decimal places, even here, this would be a 3, so 0.003, that's going to happen 0.3% of the time, or tenths, hundredths, thousandths, about 3 times out of 1,000, that's going to happen.